Okay, in this video, we want to try to solve the integral of the hyperbolic cosecant of x dx. And hopefully you've had a chance to look at the videos where we tackle the hyperbolic secant of x. And in this one here, we want to start off same thing as we did originally with the hyperbolic secant of x. That is, by using the basic definition and rewriting the integral then like this, we'll have 2 times the integral of dx divided by e to the x subtract e to the minus x. 2 divided by this, that's the hyperbolic cosecant. Now, let's do the subtraction. We have e to the x subtract 1 over e to the x. So that will be equal to 2, the integral of dx. And down here we're going to have e to the 2x minus 1 divided by e to the x. We can take that upstairs. So we get this. Now let's look at this integral for a moment here. E to the x divided by e to the 2x minus 1 dx. Now when we had tried the same approach with the hyperbolic secant of x dx and used the basic definition, when we got down to this stage of the game, we had the same integral except we had e to the 2x plus 1. And then we went ahead and tried to solve that integral with the u du pec substitution. But look here, in this case we have e to the 2x minus 1, so here we have the difference of 2 squares. So we can write the integral like this. And this might make all the difference in the world. Here we'll have e to the x divided by e to the x plus 1 times e to the x minus 1 dx. And this sets us up for using partial fractions. So here we have e to the x divided by e to the x plus 1 e to the x minus 1, and these are both linear factors. They're both to the first power, so this would just equal a over e to the x plus 1 plus b over e to the x minus 1. So multiply both sides of the equation by this. There's 2 unknowns we have to solve for now, a and b. Multiply both sides of the equation by this, and we'll have e to the x equals a e to the x minus 1 plus b times e to the x plus 1. Well, let's see, if we multiply a to the ex, b to the ex, we'll have a plus b times e to the x plus b minus a. Okay, and here we have e to the x times 1, so a plus b equals 1. There are no constants on this side. Here we have 2 constants, so b minus a must equal 0. So we have 2 unknowns, and we have 2 independent equations. Let's see, if we add these together, 2 times b is going to equal 1. So b equals 1/2. Then a will have to be equal to 1/2. Okay. So a is 1/2 and b is 1/2. But actually, this is being multiplied by 2. So if we multiply this by 2, a is 1, multiplying this side of the equation by 2, and this becomes 1. So let's see what we have now. This integral here is now going to be the integral of dx divided by e to the x plus 1 and plus, make some room here, plus the integral of dx over e to the x minus 1. Now let's look at this here. We can't handle this with a u du type substitution. But here's where we might be able to try something. See, if we multiply the denominator here, not by e to the plus x, but by e to the minus x, that would be 1 plus e to the minus x. We also have to multiply upstairs by e to the minus x. So we'd have e to the minus x divided by 1 plus e to the minus x. That might work. So let's look at this. We have this 1 over e to the x plus 1. And we're going to multiply top and bottom by this. And the reason for doing that is, you see, up here we're going to have e to the minus x. And down here we multiply through, this will be e to the minus x plus 1. Now I can use a u du substitution here. If I call this u, du will be minus e to the minus x. So we go back over to here. Rewrite this integral. It is e to the minus x divided by 1 plus e to the minus x dx. And we're going to do the same thing here, it looks like. So again, let's just write it out to make certain we don't make any mistakes. We have 1 over e to the x minus 1, multiply top and bottom by this. We have e to the minus x on top, and we'll have, this will be e to the 0, which is 1, minus e to the minus x. Okay, so let's rewrite this integral. We'll have plus the integral of e to the minus x divided by 1 minus e to the minus x dx. And these we should be all set to handle. Before we do, though, we might run out of time on this video before we have a chance to completely finish the problem off. Let's leave it at this, right here, and come back and join us in the next video, and we will finish it. We're going to leave it right where it is. Come back, we will integrate these, and then see where it takes us from there.